Welcome back to All This Math. This is Professor Parker. If you're here, make sure you hit the like button. If you're not subscribed already, go ahead and hit the subscribe button. Also, if you have any questions about anything I put up on this board, make sure you put your questions in the comments and also share this video with some other people. All right, so for today's lesson, we're going to be solving systems of equations, but we're going to use what's called the elimination method, right? Because we're going to eliminate one of the variables. Some textbooks call this the addition method because you also end up adding the top equation to the bottom equation. All right. So if you have any questions, all right, you got a question?
Yeah, so how many different ways can you solve a system of equations?
All right. So the total amount of ways, I'm not sure, but I know there's the elimination method, number one. There's the substitution method, which is another method. There's the graphing method, right? Where this is a linear equation, that's a linear equation. So the graphs of these will look like lines, look like straight lines, like on a XY coordinate plane, right? And where they intersect, the coordinates of the intersection point would be the solution, right? That would be the solution. There's also something called Cramer's rule, which deals with matrices, all right? Which, I think I might have some videos on my channel about that already, but if not, I'm going to add them at some point. All right. So that's at least four. That's at least four methods that I know of. Of course, there are probably more that I'm unfamiliar with, or maybe I'm just forgetting right now. Yeah.
I do have another question. So what exactly is a matrix?
A matrix?
Yes, a matrix, rather.
It's a collection of numbers. It's a collection of numbers organized in rectangular format, where you have rows of numbers and columns of numbers, similar to an array. If you remember, like back in probably second grade, third grade, when you were introduced to multiplication and you were shown arrays, which were like, different, dots or squares or little toys, pictures of toys or whatever, just to show how multiplication is repeated addition. A matrix is singular. Matrices are plural of a matrix. And it's a collection of numbers, kind of like how these coefficients are organized. You got a row of numbers, you got another row of numbers, you got column, 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 like that. All right, any more questions?
No, not yet.
All right, so look, we're using the elimination method. All right, we're not using substitution. Well, not the substitution method, even though the funny thing is, when you're using the elimination method, even when you eliminate, you still got to end up substituting after you solve for the first variable. Now, everything in math is called what it's called for a reason. All right, so this is called the elimination method because we're going to eliminate one of the variables. As you notice here, we got two variables. We got an X and we got a Y. We got an X and we got a Y. And what we want is to simplify to the point where we only have one variable. So I got to make a decision. I got to exercise my power and decide, am I going to eliminate the X or the Y? So what do you think I should do?
I'll say eliminate the x's first because it's going to be easiest.
Why is that going to be easiest?
Because those two terms cancel each other out. Because a negative 5x plus 5x, they'll make that 0.
But why would they cancel out?
Because they're inverses of each other, opposites of each other.
But why would you be in a position for them to cancel out? Is what I'm getting at. Reason is because the process, like I said, some textbooks call this the addition method because you're adding the first equation to the second equation. That's part of the process. We're going to combine or add this equation to this equation. And when you add this term to that term, negative 5x plus 5x ends up being 0. 0x. 0x is nothing. It's nothing. It's gone, right? Then you add negative 3y plus y. So the thing is, these are already opposites or inverses of each other. So there's no extra work you got to do if you want to eliminate the x's. If you want to eliminate the y's, you got to do some extra work because this is a negative 3 and this coefficient. What happens when there's no coefficient? What's the coefficient?
You're going to assume it's 1.
You assume it's because it is a 1, right? But if it's not written, we know it's a positive 1. It's an invisible positive 1. Negative 3 plus 1 don't add up to 0. So the y's wouldn't get eliminated because you only get eliminated when you end up with 0 for your coefficient. So you'd have to do extra work, which is we would have to multiply this whole bottom equation by positive 3. Why positive 3? Why would you multiply by positive 3?
Because the coefficient of the y in the top equation is a negative 3.
And so again, keep going.
Oh, using the addition method, that's how you cancel out those two terms because they're inverses.
So tell the story though. Tell it like it's a story. Every math problem is a story. So what will happen is if I multiply this bottom equation by 3, This is going to change to a 15x. This is going to change to a positive 3y. This is going to change to a negative 66. I'm multiplying everything by a positive 3.
Right.
Then in the next step, I'm going to do negative 3y plus 3y. Negative 3 plus 3 adds up to 0, which means that this would end up being 0y, and 0y is 0. It's nothing, because what's 0 times y? 0. So that means I would have eliminated the y's, right? But you said just eliminate the x's?
Yes.
Because it is easier, because they're already inverses of each other. Inverses or opposites of each other. So if I add these up, these are going to cancel out. And then I'm going to have negative 3y plus the invisible 1y. What's negative 3 plus 1?
Negative 2.
Negative 2. So we got negative 2y. And what's 36 plus negative 22?
It's going to be 14.
14, right, because that's the same thing as saying 36 minus 22. That's 14. So we got negative 2y is equal to 14. So now how do I get y by itself? So now look, but hold up though. I eliminated the x's. So now I'm left with an equation with just one variable. And that's what I wanted. That was my goal. My goal was to create an equation by adding these two equations together where I end up with an equation with just one variable. Now I don't got the x and the y. The x and the y, I just got one variable, right, that I can focus on. So what do I do next?
Then now you want to cancel out your coefficient because you want to get y on the left side by itself.
Yeah, you say cancel out, but it's like what operation would I do?
Or you divide negative 2y by negative 2 to make that a coefficient of 1.
How come I don't add negative 2 or multiply by negative 2?
Because the negative 2 is the coefficient of y, and that's the technically being multiplied by the variable. And the opposite of multiplication is division.
So the rule is in algebra, when we're solving equations, whenever you want to get rid of a coefficient, you do the opposite operation from what that coefficient is doing. So this negative 2y, this negative 2 is being multiplied by y. So you always ask yourself, what's the opposite of multiplication? What's the opposite of that operation? And that's what you do to get rid of that thing you try and get rid of. So I'm trying to get rid of this negative 2. So the opposite of multiplying negative 2 is dividing by negative 2. And why did I divide it over here?
Because whatever you do on one side, you got to do on the other side too.
What's your question?
So I was going to ask, so essentially you're saying that to undo something, you got to do the opposite operation.
Right. Okay. You got to do the opposite operation. You're doing the opposite operation. So this negative 2 divided by negative 2 is equal to positive. This becomes a 1. This becomes a 1. So we end up with 1y over 1. And that's equivalent to y. 1y over 1. That's math language. So you got to make sure you know the language of math and know the language of algebra. So you know that this all simplifies into just plain y. And then what's 14 divided by negative 2?
It's going to give you negative 7.
How come it's not positive 7?
Because the positive divided by negative is going to give you a negative.
Always. It's always going to be a negative. And also, don't confuse the rules of multiplying and dividing positives and negatives with the rules of adding and subtracting positives and negatives. There are different rules, right? Different rules. All right, so we got negative 7 for y. So now we go back and we can figure out what x is. We pick one of these equations. Which equation would you pick?
I'll pick the second one.
The second one? Any reason?
Yes. Because there's no coefficient. Well, it's basically just less work to do. All you have to do is plug in the negative 7 into the equation for the y.
Instead of with the first equation, you got to multiply negative 3 by the negative 7, right?
Right.
All right, so we can do the second equation now, but does it matter though? Could you use the first equation if you wanted to?
Yeah, definitely.
You can use either one. So you got 5x plus negative 7. Don't forget the negative sign. Don't forget the negative sign. So put the negative 7 in parentheses. That equals negative 22. So what would your next step be?
Just for the sake of making everything look neat, I would drop that positive sign with a addition sign. Just substitute, well, not substitute, but just write out 5x minus 7 equals negative 22.
Okay. Because adding a negative is the same thing as regular subtraction. Adding a negative is the same thing as what I call straight subtraction. So we got 5x minus 7 equals negative 22. This is equivalent to this. This equation is equivalent to this equation. Plus a negative is the same thing as regular subtraction. All right, now what would you do next?
Gonna get rid of the constants that are on the same side as the variable first. So you're gonna add 7 to both sides.
Again, right, because the opposite of subtracting 7 is adding 7. Opposite of subtracting 7 is adding 7. So we're going to do plus 7 right here. Do it on both sides. Plus 7 over here. Boom, boom. Bring the 5x down. What's this add up to?
You're going to use negative 15.
So 5x is equal to negative 15. And then how do we get x by itself?
Just like how we did earlier, you're going to have to divide 5x by 5.
So we're going to divide by 5. Do you ever divide by the variable?
No.
Exactly.
But you're solving for the variable.
A lot of students make that mistake. Don't be one of those students. Do not make that mistake. You're not dividing by 5x. You're only dividing by 5. Always keep in mind, what is your goal? Let your goal inform what your steps should be. I don't divide by x because if I divide by x, then I would basically be eliminating the x. I don't want to eliminate the x right now. I want to isolate the x. I'm trying to solve for x. So I'm trying to get rid of everything except for x. If I divide by 5x, then I'm getting rid of the x too. It's like you being in a room with two other people and you want to be in the room by yourself. You want them to leave. You do not leave. You want to be in the room by yourself. So you want those other two people to leave. If you leave with the other two, then what's the point? I thought you wanted to be in the room by yourself. We want the x to be in the room by itself. So we want to get rid of this 5. We do not want to get rid of the 5 and the x. We only want to get rid of the 5. So that's why we only divide by 5. And we keep it balanced. So we divide by 5 on the left. We divide by 5 on the right. 5 divided by 5 is 1. So that means we have 1x. 1x and x are equivalent. That's the language of math and the language of algebra. So then we got negative 15 divided by 5, which is that positive 3?
There's going to be a negative 3.
Why?
Because a negative divided by a positive is going to give you a negative.
Right. Rules of arithmetic. A negative divided by a positive always equals a negative. All right. So we got x equals negative 3 and y equals negative 7. I think this is the answer, but you should always go back and check your work because in algebra, just like in mathematics, correct answers give us the truth, a true statement. Math is about finding the truth. So what's negative 5 times negative 3? That's 15. Nasim, what's negative 3 times negative 7?
Negative times negative 7 is going to give you positive 21.
So this is going to be plus 21. Now the question is 15 plus 21 equal to 36?
Yes.
So that means that this solution works for the first equation, but in a system, the solution is only valid if it works for every equation in the system. Notice I say every equation because this system only got 2 equations. You might have a system that's got 3 equations, 4 equations, 5 equations. You're probably not going to see none with more than 3 though, but you know what I'm saying? Like this one got 2, so it's got to work for both equations because you might encounter a situation where you have a solution, an x and a y value that works for one equation but not the other one. So don't get all hype and be like, oh, it works for the first one. I'm done. I got it right. No, you got to make sure it works for both equations, not just one of them. So then we go here. We do 5 times negative 3 again. Well, not again, actually. What's 5 times negative 3?
Negative 15.
So we got negative 15 and then plus the negative 7. Y is negative 7. So negative 15 plus negative 7. Does that equal negative 22?
Yes.
So then that's true. So it gives us 2 true statements. So that means this is the answer. Now, if we had used the graphing method and graphed this equation on a XY plane, y-axis, x-axis, right? Then where these lines cross each other would be at this point with these coordinates. Negative 3, comma, negative 7. That's where is that at? Negative 3 down, it'd be like down here somewhere, right? That's where they would cross each other. That's the intersection point, That's where they would cross each other. All right, so that's the solution to this system of equations. The only place where they intersect is at this point right here, negative 3, negative 7. All right, that's the intersection point where, you know what I'm saying, where everything meets up. So we use these in business a lot to, you know, find good price points, right? When you're selling a product, you want to make sure you want to find out like what's the best price to charge, where you'll make a certain amount of profit. You know, you won't end up having to spend too much, you know, all of that, right? That's one of the things we use algebra for. But besides that, we use algebra to develop our problem-solving skills and develop our critical thinking. So we don't got to be looking stupid out here in the world because we got critical thinking ability. All right, so that's one of the main things algebra is good for, in case you wonder, why I got to learn all this? When I'm going to use this in life? You use it because it helps to build your brain, helps to help you to learn how to think and understand how to think. All right, which is a skill that you need anywhere you go, no matter what situation you're in. It's not just about knowing how to solve a system of equations, because you might not be in a grocery store and have to take out a piece of paper and solve a system of equations, but you need to be able to think mathematically in any situation in life, no matter where you at, who you with, who you talking to, who you dealing with. And the people that can't think mathematically get taken advantage of every day. And it's even worse that, because somebody might hear me say this and be like, man, you don't know what you're talking about. Right. Because a lot of you people Unfortunately, they get taken advantage of, do not even know you're being taken advantage of. That's what the good scammer can do. A good scammer can take advantage of you. You won't even never know it, right? The bad scammer, you're going to figure it out, 5 minutes later, right? But talented scammers will let you know, you will never know that you got scamming unless you can think mathematically. All right. So that's the benefit of learning arithmetic, learning algebra, learning geometry, especially geometry, learning pre-calculus, statistics, all of that. So you can think mathematically and in a mathematical way so you can understand things and make sure that things make sense, okay, in case you was wondering. So if you're here and you ain't hit the like button yet, go ahead and hit the like button. If you still ain't subscribed, hit the subscribe button. Also, share this video with at least two people, at least two people. All right. And if you still got questions, put your questions down below in the comment section. All right. See y'all later. Peace.